All right, everyone, welcome back. Ready for another deep dive? Today, we're going to be tackling AI inferencing, which I know can sound, well, a bit technical, but trust me, it's really fascinating once you get into it.
Absolutely. It's where the rubber meets the road with AI.
Exactly. And thankfully, we've got this excellent paper to guide us, AI Inferencing, Optimizing Machine Learning with CPUs and GPUs by Danny Hekaroff.
A great choice. It really demystifies the whole process.
Yeah. So before we get lost in the jargon, maybe we can start with a simple analogy, like, think of it like learning to ride a bike.
Okay, I like that.
Machine learning is like practicing, getting the balance, figuring out the pedals, all that training.
And AI inferencing is like, actually going for a ride, putting those skills to use navigating the real world.
Exactly. And just like with bike riding, there are different ways to learn, different approaches. And the paper talks about these three main types of machine learning.
Right. Supervised, unsupervised, and reinforcement learning.
So supervised learning, is that like having someone like a coach right there with you, guiding you through every step?
Pretty much. It's like, imagine you're trying to teach an AI to recognize different types of birds. So you give it a bunch of pictures, right? But each picture is labeled. This is a robin, this is a sparrow, and so on. And the AI learns by connecting the image with the label.
Oh, so it's learning from examples.
Exactly. And over time, it gets so good that it can identify a bird just from a picture, even if it's never seen that specific bird before.
So what about unsupervised learning? Is that more like, just being thrown out there with a bike and figuring it out yourself?
Yeah, kind of. This time, you give the AI data, but no labels. So it's like a giant puzzle. The AI has to find the patterns and relationships on its own.
Sounds challenging.
It can be, but it's also how AI can discover things that we might not have even noticed. Like, imagine analyzing a ton of customer data. Unsupervised learning might reveal hidden segments, like groups of customers with similar buying habits, that you could then target with specific marketing campaigns.
Oh, that's interesting. So it's about uncovering those hidden connections.
Exactly. Now, reinforcement learning, that's the really fun one.
Okay, how so?
This is where the AI learns by trial and error, kind of like, playing a game. It tries different actions, sees what works, what doesn't, and gets rewards or penalties based on its performance.
So it's like learning by doing, by interacting with its environment.
Exactly. This is how they train those AI systems that can beat humans at complex games like Go or chess. Or think about self-driving cars. They learn by driving around in simulations, figuring out the best way to navigate and avoid obstacles.
So all of this learning, all these different approaches, they lead to what's called a trained model, right? Which is what AI inferencing actually uses.
Right. That trained model is like the culmination of all that learning. Like, the AI's knowledge base.
Okay. But how does that knowledge actually get put to work? Like, how does AI inferencing take that model and use it in the real world?
Well, think of it like, let's go back to that bird watching example. You've trained your AI on tons of labeled bird pictures. Now, you take it out in the field, you see a new bird, you snap a photo.
I know.
That's where AI inferencing kicks in. It takes that new photo, analyzes it using the trained model, and predicts what kind of bird it is.
Ah, so it's like applying what it's learned to a new situation, a new challenge.
Exactly. And that's happening all around us every day, often without us even realizing it. Like, think about your phone's facial recognition. That's AI inferencing in action.
Oh, yeah. Or those spam filters that keep our inboxes clean. Or those personalized recommendations on shopping sites.
Precisely. It's all AI inferencing working behind the scenes, analyzing data, making predictions, and helping us navigate the world.
And a lot of that, as this paper points out, depends on two key pieces of hardware, CPUs and GPUs.
Right, but there's this common misconception that GPUs are the only heroes in the AI story.
Yeah, I've heard a lot about those super powerful graphics cards that people use for AI.
And they are crucial, especially for those really complex models. But it's not as simple as just, throwing more GPUs at a problem.
So are you saying that CPUs, those chips that power our computers, are they important too?
Absolutely. While GPUs excel at parallel processing, crunching those massive amounts of data, CPUs are like the multitaskers. They handle all those other essential tasks that keep everything running smoothly.
Okay, so what kind of tasks?
Well, think about it. Before the GPU can even start working its magic, the incoming data needs to be pre-processed, right? Cleaned up, formatted, organized. That's a job for the CPU.
So it's like the CPU is the stage manager, setting everything up for the main performance by the GPU.
Exactly, and it doesn't stop there. Once the GPU has done its analysis, the CPU steps back in to handle the output, formatting the results, sending them to the right place.
So it's really a team effort then.
Absolutely, and that's what this whole hybrid approach is all about. Using the right tool for the right job.
All right, I'm definitely intrigued. We're going to get into the nitty-gritty of this hybrid approach and explore some even more fascinating stuff after a quick break. Don't go anywhere.
Welcome back, everyone. We were just getting into this idea of a hybrid approach to AI inferencing using both CPUs and GPUs. And, it might seem kind of technical, but it's actually really easy to grasp once you see it in action.
Yeah, I get the concept, the teamwork aspect, but can we maybe walk through like a specific example just to really see how it works?
Sure, let's take that facial recognition example. You upload a photo to your favorite social media platform.
Herman's all the time.
Right. So behind the scenes, the CPU kind of jumps into action first. It handles all those initial tasks, like loading the image from storage, maybe resizing it, getting it ready for analysis.
So it's like prepping the data.
Exactly. Making sure it's in the right format, maybe adjusting the colors, brightness, just to make sure everything's good to go.
Okay, so the CPU is like the sous chef, getting all the ingredients prepped and ready for the master chef, which is the GPU.
I like that. Perfect analogy. So once the CPU's done its thing, it hands off the prepped data to the GPU. And this is where the GPU really shines, using its parallel processing power to run those complex algorithms, identify the faces, match them to profiles.
And suggest tags, right? Like, hey, isn't this so-and-so?
Exactly. But even after the GPU's done all that heavy lifting, we're not quite done. Those results, they need to be, formatted, sent back to the app.
And who takes care of that?
The CPU steps back in, might receive a list of faces, their confidence scores, all that stuff. It then has to organize it, maybe add the tags to your photo, and then boom, everything appears nicely on your screen.
Okay, so it really is like this back and forth, like a relay race almost.
Absolutely. And the cool thing is, this hybrid approach isn't limited to just, facial recognition. It could be used for, well, pretty much AI inferencing task you can think of. Natural language processing, recommendations, fraud detection, you name it.
Wow. Okay, so this is pretty powerful stuff. But the paper also mentions some ways to make AI inferencing even more, I guess, efficient, right? Like squeezing even more performance out of the system.
Oh yeah, there's some really neat techniques. One that I find particularly fascinating is model compression.
Model compression.
Yeah, it's basically making the AI model itself smaller and more efficient without, and this is key, without sacrificing too much accuracy.
So it's like, if you're going on a trip and you have this huge overstuffed suitcase, you want to make it lighter, easier to carry, but you don't want to leave behind any of the essentials, right?
Perfect analogy. And there are different ways to do this. One common technique is called crooning. It's kind of like identifying the parts of the model that aren't really contributing much and just, getting rid of them, trimming the fat, so to speak.
So you're making the model leaner, but still effective.
Right. And then there's quantization, which is, well, it's a bit more technical, but essentially you're reducing the precision of the numbers used in the model. So instead of storing them as these, high precision values, you use lower precision ones, which take up less space.
So it's like using a smaller unit of measurement, like switching from, inches to centimeters.
Exactly. It's all about finding those clever ways to represent the model's knowledge more efficiently without, and this is always the goal, compromising its accuracy.
This is all very impressive, but I gotta admit, it's getting pretty technical. Is this something that, the average person even needs to worry about?
Well, you don't need to understand the nitty-gritty details to appreciate the benefits. The key takeaway is these techniques, they're all about making AI inferencing faster, more efficient, and ultimately more accessible.
That means quicker results, whether it's, unlocking your phone with facial recognition or getting a medical diagnosis. And it probably saves energy too, right?
Absolutely. A smaller, more efficient model needs less computing power, and that translates into lower energy bills, maybe even more affordable devices.
Okay, so this isn't just theoretical, it has real-world impact. And what about the hardware side? Are there other things besides CPUs and GPUs that are being used for AI inferencing?
Oh yeah. The paper mentions these things called FPGAs and ASICs. Might sound like alphabet soup, but they're basically custom-designed chips that are super efficient for specific AI tasks.
So instead of using like a general-purpose chip, you have one that's tailor-made for a specific job.
Exactly. It's like, think of a Swiss Army knife. It can do a lot of things, but it's not going to be the best tool for every job. Sometimes you need a specialized tool like a high-powered drill or a precision screwdriver.
And that's where ASICs come in?
Right. And because they're so specialized, they can perform those specific tasks much faster, much more efficiently. Like, for example, in natural language processing, companies like Google and Amazon are developing custom chips specifically for, speech recognition and translation.
Oh, wow. So it's like having a dedicated language processor.
Exactly. And this whole trend of specialized hardware, it's only going to accelerate in the coming years as AI inferencing becomes even more, demanding.
Speaking of the future, the paper also talks about something called edge computing, which sounds, well, kind of futuristic.
It is pretty futuristic. The idea is basically to bring the AI processing closer to the source of the data. So instead of sending all your data to the cloud, you could process it locally on your device.
So, like, my smartphone could run complex AI models without needing to connect to a server.
Exactly. And that means faster results, more privacy, and you're not as reliant on a network connection. Think about, like, self-driving cars. They need to make split-second decisions. They can't be waiting for instructions from the cloud.
That makes sense. But, if all this processing is happening on our devices, what about privacy? How do we make sure our data is safe?
That's a great question, and it's something that researchers are working on. There are techniques like federated learning, where models can be trained on data that's spread across multiple devices, but without actually sharing the raw data itself.
So it's like sharing the insights without sharing the actual data.
Exactly. It's all about, balancing the power of AI with the need to protect individual privacy.
This is mind-blowing stuff, and we've covered so much ground already, but we are unfortunately running out of time for today's deep dive. We'll be back soon to wrap up this incredible journey into the world of AI inferencing. Wow, that was a lot to take in, but really fascinating stuff, right?
Definitely. AI inferencing is, well, it's a game changer.
So before we wrap up this deep dive, can we maybe try to distill like the key takeaways for our listener? What are the most important things to remember about AI inferencing?
Okay, so I think first and foremost, it's realizing that AI inferencing it's not just some theoretical concept, right? It's happening all around us right now.
Yeah, it's powering so many of the technologies we use every day.
Exactly. And then I think it's also understanding that, AI inferencing it's not a one-size-fits-all kind of thing. It's about finding the right tools, the right techniques for the specific task at hand.
So it's not just about, throwing the most powerful hardware at a problem. It's about being smart, about optimization.
Right. And then I guess the third takeaway would be, well, just this sense of excitement about the future of AI inferencing. This field it's moving so fast. There are new breakthroughs happening all the time.
Yeah, like that edge computing thing we talked about. That's pretty mind-blowing.
Absolutely. The potential is, well, it's almost limitless. But of course, with any powerful technology, there are always, potential risks, ethical considerations.
Like data privacy, algorithmic bias, those are big ones.
Definitely. And I think as AI inferencing becomes more and more prevalent, we need to have these conversations, right? We need to think about how we can ensure that it's used responsibly, ethically.
Absolutely. It's like we're not just building a tool, we're shaping the future.
Well said.
Well, I think that's a great place to leave it. A big thank you to you for sharing your expertise with us.
It was my pleasure. Always happy to talk about AI.
And of course, a huge thank you to Danny Heckeroff for his insightful paper.
And to all of you listening out there, keep exploring, keep learning. The world of AI is waiting.
Until next time, stay curious.